Hello, once more. Welcome to Leopard Street. Welcome to the cellar. Now, in previous videos, I have mentioned the electrical power problems this layout has got. There's been occasional mentions of I'm running trains and things just reset, things restart. Recently, powering the board A up, the rear wires. Yeah, there's problems. Now, there's two ways of fixing this. I could bodge it, or I can do it properly. And for once, possibly the first time in my life, I'm doing it properly. Let's have a look and see if we can get this working. This is Leopard Street. Okay, here we are at the desk. We'll have a little look at this before I go into it. And this is pretty much what I've currently got. There's a power box on the wall. There is actually another little power box that sits underneath. That has got in it, mains power comes in. That has got a 5 volt, a 12 volt, and a 15 volt DC supply system. And it's got little displays on it that tell me what it's doing, and it's all well and good. Reasonably happy with that. That has got some wires that come out the bottom, and it's got a connector, and these little green loops. The connectors are this sort of thing. These are decent ones. The ones I've got on the layout are actually cheap, nasty ones. And basically, it's a plug and socket connection. You put screw terminals in one end, so you put ferrules and wires, and they go in. This is a 12-way. Yeah. Reason for this, Leopard Street consists of currently 9 boards. So they're in blue, A, B, C, D, E, F, G, H. I is the most recently added diagonal one. There is a lowercase d, f, g, and h sitting on top of this, and another little one at the end. Not talking about those for the moment. Basically, they're not really powered up. The lowercase d connects into the one underneath it. So what we've got, each board has in red an electrical panel. On that panel lives its ESP32 board controller. There's the PCA 9685 relay controllers and servo controllers. All that sort of stuff lives on there. And between them are these green bus wires. And all of these loops are this sort of connector. These are 6-way connections. Each one carries 5 volt logic. And by logic, I mean that drives ESP32s, that drives relay control boards. It's driving the little input-output boards. Basically, anything with a microchip. I have 5 volt power. Now, this was the first attempt at fixing this problem, because this started when I was back just over here, and I decided to bodge it. Yeah. At 5 volt power, it's a separate power supply. It drives relay coils and servos, and that's it. Now, I'm actually going to keep that. It's not part of this box. It's a separate brick that sits on the floor. And it has got its own sort of connector that comes in and feeds into there. And I'm going to keep that because I found it's actually quite useful to be able to turn the layout on, wait for the layout to boot up properly, then power up the servos and the relays. So I'm going to keep that. But that connects into this panel on board C. Each of the panels has a little distribution bus. We'll have a look at one in a minute. There are some screw terminal connectors along the top. Typically, the arrangement looks, I say we're going to have a look, but it's typically it is a screw terminal block, another screw terminal block, and then a little one on the end. And the little one on the end was added later. That is 5 volt power. This one here is split. It typically has got ground, 12 volt and 5 volt. This one tends to be split. This is DCC. These are the 2 channels, and these are spares. And the spares get used for points and so on and so forth. Now, as you can see, the green wire runs all the way around the layout. So power to board F comes in here. It can go via B, A, D, and F, and it also goes via sort of E, H, G to F. And if I need 5 volts over here, it's drawing current both ways. It's a ring main. basically what you've got in a house. Except there are connectors here, here. So the power comes in through a connector into a screw terminal, comes out of a screw terminal into a connector, comes out of a connector into a screw terminal. Every one of those connections is adding a little bit of resistance. The screw terminals aren't too bad. These things, it seems, are. I say this is a good quality one. This came from Switch Electronics, and it's good. It was supposed to be in a pack of 5. It turned up in a pack of 1, and I got a bit of a refund as a result of that. But never mind. That works. To be honest, these wouldn't work for the layout. These are too stiff. So put that to one side. The idea behind doing all this is Leopard Street comes apart. There are bolts between these boards. I can dismantle them. What I could do is just put my hand underneath and pull this little jumper cable out. Undo 2 bolts, undo 2 more. Lo and behold, this section comes out. Brilliant. However, what this means is there is a resistance between each of these. So where I'm supposed to have 5 volts over here, I haven't. So what we're going to do in a minute, I'm going to have a look at what we're going to be doing with the layout. But I'm going to go around and I'm going to measure, I'm going to power the layout on, and I'm going to measure the 5, the 12 volt and the DCC voltages on each of these panels. Because when I did this the other day, board D didn't have 5 volts on its logic bus, it had 3.7 volts. That's a problem. And we'll have a little look on the back here. Now the reason this is a problem is I have ESP32s. Now these are microchips that sit on a board. And on this board there is a power supply. And it takes 5 volts in and it turns out 3.3 volts. That has a voltage drop across it. No matter what you do with it, I mean, you can feed a little bit more than 5 volts in, but that has a drop of between 1.5 volts. So if that dips much below 5, you don't get 3.3 volts. ESP32s behave a little bit weird when they don't get the voltage they like, especially when they try and turn their Wi-Fi on their little antenna. That draws quite a bit of current. If it hasn't got 3.3 volts, it tries to draw too much current on it, the voltage drops further, that switches itself off. That's what's been causing the resets, is this 5 volts dips a little bit. Originally, I'd have, say, a servo motor over here. It goes either way. And I would say to that, change. And it would move, it would hit a stall point or whatever during its startup sequence because it would try to go full-scale deflection. That then draws more current. That dips that voltage briefly. The board controller resets and it goes round and round in a loop. So, that's what I've currently got. It sort of works. It's a bodge. Good quality connectors, it might work. However, what I'm actually doing is I'm moving over to this. Now, this is a spur configuration. It's like a star wiring. So I'm putting in a new panel. This is this grey piece of wood I showed the other day. The power box is going to talk to that via a little connector because that still needs to be undone and I'm not changing the design of the power box. Board I is still going to have a jumper connection to board G because that needs to be quickly removable, basically so I can get into the corner. However, each board is then going to be wired directly to a power distribution board via screw terminals with proper spade connectors on either end or some fork terminals into the screws on either end. This means taking the layout apart is going to be more complicated because I will have to unscrew a lot of wires. In practice, I'm hoping not to take the layout apart again if I can get away with it. So this panel will take the 3 voltages in, the 5 volt logic, 5 volt power and the 12 volt and ground. It'll also have the DCC bus, but I'm not touching that today. And then board A will connect directly to it, not via board B. There'll just be a wire. B will connect to it, C will connect to it. So board F round here and D where I've had the problems are now going to connect directly to this. They're not going to be going via multiple connections. They're going to connect in directly. But let's go have a little look at one of these boards. I'm going to switch things on and I'm going to measure some voltages. That's how we're going to look at why we're starting now. Now here we have a power panel. This is board D. Here are the screw terminals in. I've got the 2 DCC channels. I've got some spare terminals here. Ground, 12 volt, 5 volt, 5 volt power. This is currently resetting itself. There are relays chattering a little bit. So what I'm going to do, I'm going to take my multimeter, my trusty multimeter. I'm going to put it on the 20 volt range. I'm going to have to put the thing on the top here so I can get hold of it. And I'm going to measure what the voltages I've got are. And I'm going to write them down because I want to know what the performance increases. So what I'm going to do is I'm going to start on here and I'm going to say, what is my 12 volt circuit? So I go to that point there, that point there, and that is 11.8 volts, which is not bad. So that is 11.8. The 5 volt power is this side, which is 5 volts. See, sometimes bits of this work, and then I've got the logic, which is there and there, which is 4.3 volts. So that's better than it was the other day. But it's enough these relays are chattering. And the DCC power, the track power isn't on at the moment, so I'll have to do that later. But that's just chattering away these little relays. There are some lights on them. A little look. It's not going to do it while I'm looking at it. There we are, flickering and changing. And essentially, it's all the connections here are just a little bit ropey. So yeah. So I'm going to do that to the rest of the panels. I'm going to measure the DCC voltage. I'll be back in a minute and we'll have a look. This is an example of the problem. This is the clicking sound. These are these 2 relays here going bananas. And all I've done is drop that board. So yeah, this is where we have some serious problems. So I'm going to read through the measurements. I'll be back in a minute. Okay, here we are. The relay chattering was driving me mad, which is why I've not done the DC bus ones. So as you can see, the 5 volt power circuit, it varies. C is where the power comes in, remember. That's the distribution. Everything goes from there. So that being the highest voltage is not surprising. And the 5 volt power goes down to 4.7. So, yeah, a 0.3 volt drop. The logic starts at 5 down to 4.2 on here, which is a 0.8 volt drop. And I've seen that be worse. That has gone over 1 volt as a loss. Over here, 11.9 down to 11.2. Yeah, 0.7. So I've got volt drops. They're not massive. There was another alternative for this, which was actually use the 12 volt auxiliary bus with buck converters to get a reliable 5 volt supply for each panel. That's not really addressing the problem. That's sort of addressing the symptom. So what I'm going to do, we're going to go back over to the layout and have a little look at what we're actually going to do to create this wiring method. Now, the first parts I'm going to do is the 5 volt logic and the auxiliary. The power side's going to wait. Basically, I haven't got all the wire to do it. So anyway, to the layout, let's go and have a look. Okay, my screwdriver is charging, so there'll be a slight delay on that side of it. But this is the panel, 3202 wire. Orange for 12 volts, red for 5 volt logic, black for DC ground. This came via Railway Scenics. My thanks to Steve and Gabby. Not sponsored by the video, this is all stuff I've actually bought. But they turned this around really quickly. So yeah, a couple of days from ordering and you've got it. 10-meter lengths. I've got several packs of each. That's what I'm going to be using. I'm hoping I've got enough. Now, what I've also got are these. Now, these, if I bring these up here, these are these screw terminal blocks. These are larger than the ones I would normally use. Pitch on the ones I normally use is like that. Yeah, I ordered the wrong ones. Don't care, using them anyway. Right, so what I need to do is work out roughly how this is going. Now I need ground, logic, power, 12 volt, 2 lots of DCC. So this is going to come up here somewhere. And what I'm going to do is I'm going to fit these on the desk. It's just easier. They can be fitted offset like that somewhat. I need to see how much space they need, which means I need to just clip these. These are the bus rails you get with them, which if I can get into, I will do. My knife is somewhere. It's just somewhere. The tidying up bit I mentioned, as you can guess, I've probably not actually started that yet. I'm going to be ordering some more storage boxes next week. Well, this week, I suppose, when this video goes out. So I've just got to get into this. This is wonderful stuff. It comes really well wrapped. Unfortunately, it comes really well wrapped, which makes actually doing anything with it quite awkward. Let's see if I can just persuade these to rip the packaging. Good. Right. So what you get, one of these comes with a plastic lid, which is worth keeping. The top is smooth, so you can stick labels on the top. There are little numbers, but there you go. Now these go, you have to break them all open, but then they go into there. And what I'm going to have is one up here, ground connector. It might even be above. This is going to get stuck into a board behind it. And what I'm going to have is this side will be the input. So I'm going to have power coming down here. Have another one, which again will have another one of these connectors. I need to work the spacing out. So yeah, that's what I need to get out with this. Take the lids off all of them. And I've got some little cable clips, which I've 3D printed, which are going to go at the side. Because I'm going to attempt to keep this fairly organized. So that there, little clips, cut to take 3202 wire. And then a wire will come down through there, and it will come across, and it will come into this. Come into the next one, come into the next one. Now, as I've said, I'm only doing part of this today, but it is all going to come onto this one panel. This is going to get mounted to the bottom part of the layout, so I can work out roughly where I want these to go. They're going to spread out sort of fairly equally. I've then got 12-way connectors. The original idea was I was going to have these sit in here, and then the wires, as they come out, I can clip them in this side. I'm not sure that's going to be possible, purely because I don't think I've got the space to do it. So I'm going to do that like that, because when that's in there, it's going to make clipping some of the wires in. But so I'm going to have board A, board B, C, D, E, F, G, and H. And I've got some spares. The upper boards are not going to be connected directly to this panel, so I can get away with this. But what I'm going to do, I'm going to set this up. I am going to put a piece of wood on it. I'm going to line them up. These are just going to get screwed in. The bottom one will be below the screw. The upper one will be at the top. And now all I'm going to do is this is going to get fitted together here. It's then going to go down there, get screwed to a piece of wood. And I'm going to do all the wiring down there in situ, just because it's going to be a little bit easier to do it all in place. So I'm going to need 6 of these. I've got 3 in each colour. I could put some tape around them. I did think I could do a little 3D printed panel and such like on here. I'm not going to bother. So what I'm going to do, I'm going to get these screwed on. I'm going to get these little connector clips screwed on. Then we'll have a little look. Then I'm going to go and install it. So I'll catch you in a minute. Okay, here is the panel. I put the bus rails in. I've done a quick check. The resistance from there to there is about 1.5 ohms, which is not zero, but small enough I'm not bothered about it. Brackets are in place, so down here power can come in. The ground cable will just go straight into that. There'll be a tie wrap up here somewhere. DC 5-volt logic, come down here, 5-volt power, 12-volt, and the two DCC lines. As I've said, the power and the DCC ones are not going to be connected yet. Over here, basically 12 wires can come out and there's just some clips. It's an attempt at keeping it tidy. Over here are the 7 boards. There should be another cable clip down here. I haven't printed enough. The printer's busy at the moment. I'll print some more and I'll put another one in there tomorrow. My screwdriver is on charge, but that is now going to go under board. Originally, this was going to go on the wall. It was going to go. We'll just have a quick little explore. It was going to go on the wall at the back because that makes it directly under the power box. Then I realised no. So what it's now going to do is go onto this piece of wood here. Just get that so you can see it. Yeah, anyway, that piece of plywood there, it's got some clamps on the bottom, they need to come off. It's going to get screwed to that. That's going to happen before I do any wiring. Basically, because all the wires that way I can cut to length. So, hopefully, this will be a little bit neater. And the plan, once it's in, I'm going to route the ground, logic, 12-volt supplies. They're going to come straight in. The moment they go to board C, which is that one at the end in the corner. And what I'm going to do is I'm going to route them into here. Now, the DC ground is then going to come out one of these, doesn't matter which one, and go back into that board. Eventually, well, I think I'm going to do that. I actually don't need to because all the ground connectors are connected on the board. So when this connects to board C, it's fine. The reason being, the 5-volt power isn't going through here because I need to order some more wire, basically. I need another color of wire for this, and I need more brown and I need more blue. I'll do an order at some point. But I need all the grounds connected together. So it'll be a ground in, and then it'll go off to its board. What I'm then going to do is run the ground cables to the various boards. I'm then going to run the logic, 5-volt logic to the various boards. I may go for, I'm going to do from here to board A first. Because that means this wire will come out, it'll clip in the bottom, go up. You get the idea. Anyway, screwdriver's charging. I need a drink. God, do I need a drink. Anyway, I'm going to get some coffee. And then I'm going to be back in a bit. So I'll see you in a sec. Okay. A short while later. I forget how long it is. I have a panel. I've got a couple of things I need to just shift out of the way because this is Leopard Street. There are things in the way. It's just what happens. So hook some of these over here. Used to store these here. Yeah, I can't do that anymore. I've stored them the other side. Just get them out of the way. Yeah. So the panel's done. Screwdriver is charged. I'm now going to mount the thing, and I'm going to start looking at adding some of the wires. Still not 100% sure what order I'm going to do the wiring in, but it's one of those things. It is what it is. Right, so here's panel. Put top screw in first, because that's probably the easy way of doing it. And it's just a 25mm screw. It's nothing too serious. So lock screwdriver onto that. It's going to go about there. I just need to watch out very slightly with it. There's always something. I'm going to take the bottom power rail off because it's in the way. I'm going to adjust myself slightly. Yes, after the last time I was scrabbling around under the layout, I've gone to the trouble of finding the work light, which is probably why, with a bit of luck, you'll be able to see what I'm doing. Well, see me. Obviously, you can't quite see what I'm doing here. Let me just realign the camera slightly. Taking that out so I can get this screw into its hole, get this board roughly vertical. Yeah, it's only going to be roughly vertical, but it'll do. That. That's that. That can slot back in there, like so. I'll just nip these up. Now this is obviously going to get the little plastic covers put back over it eventually. Once I've finished what I'm doing. So the next thing I need to do is hook up the power to this. And that is going to come by disconnecting it from board C, which these are the legs for, the panels there. So let's have a look at doing that. Yeah. Needless to say, everything is in the way, as it always seems to be around here. Right, so lift you up like that. This is the first board I need to remove. Now, what I need is the power input wires. Now, I've got the connector back here, so I can see what I'm doing with it. That one is one of them. That one is another. And that one is the third. So let's tip those back up. Now I'm going to be removing a lot more from that. I'm also discovering I'm going to need a knife probably, because there is a fourth wire here, which is the white one. The white wire goes to the other board. So I'm just going to cut all this. I'll be back in a sec. Okay, remove this. There was an extra connector, which I wasn't expecting. All right. That end goes into the power box. This end goes into a connector on the bottom of the layout. So what I need to do, that bit I need to keep. And I need to keep it in that order. But the first thing I need to do is remove these wires. Now I'm going to do these a little bit at a time, just to keep life simple. This 15-volt wire doesn't go to the panel on this board. It runs from that connector to the next board. So I am actually going to be replacing the 15-volt wire today. I didn't think I was going to, but I'm going to be doing that. That'll be one of the first ones I connect. I'm hoping there's enough of this. So this is 3202 in white. So I'm going to trim the ends slightly. And find a suitable ferrule for it. Out of what can only be referred to as the box. I'm actually quite pleased I've got this white wire. I didn't think I had. So what I need to do is find a suitable one of these for this stuff. I don't think the grey ones fit. Nope. Do the red ones fit, which are the next size up. They do, so red ones fit onto there. Goes on there quite nicely. Around here there is the tool for it, which makes life extremely straightforward. So that goes in there. That's that. Test that. That doesn't come out. So I just need to make sure I get this into the correct hole again. Yep. So that goes into there. Now this is going to get connected to all the different colors of wire. It's going to get plugged back into the power box, and it's then going to be dropped down the back of the layout. So the next one across is, get this correct, the next one across is orange. So a roll of orange wire I have here. I'll do the same thing to that. So this is going to get its end clipped, ferruled, and then in we go. Now this probably should get some cable ties around it, just hold all the wires together. So I'm going to do that as well. So that goes in there properly. That's that. So into the next one. Yada yada yada. Now, as I said, these are not the best quality versions of these connectors. However, they do work, and for this level of stuff that I'm doing here, these will be fine. I have the red wire, which is the next one, which is going to be the 5-volt logic side. So let's trim that. And as has been mentioned on many, many occasions now, you don't need the ferrules. They tidy things up, and if you just twist wire, you can get stray connectors, stray little strands of wire that can short out things next to it. The ferrules help prevent that, which is the purpose of them, really. So yeah, I need a black wire here, which is going to be the ground connector. Now, previously, a lot of these wires were like the 5-volt logic bus was 2402 going around. Doesn't need to carry that much current, and I figured, what the hell. Yeah, it's all 3202 now for the bus wires. Droppers are smaller than that, but the bus wires are all going to be this size. So that is that. Into there. Screwdriver that in place. Now, as I'm fitting these new cables, I'm removing the old ones. Basically, I just want to try and simplify this quite a bit. So that is now going to get a tie wrap put around it, just to help hold those together. Like that. That's now the new end for the power board. So let's go have a little look and fit that. Come around here. Yes. Inside of the power box is there, and this connector, close that, goes down there. So what I need to do is get all of this wire. Now this is going to make a mess on the floor. I really don't care. Bye. There we go. That all goes down there, and that plugs back in like that. And that's it. The layout, well, I say the layout is connected. The layout isn't connected because obviously that wire isn't connected to anything. So let us come down here. I will try and put the work light back on. I suspect its battery is going to go flat, however. So let me see if I can get this to come on and stay on at some point. Even if I have to turn it down a little bit. Right. If I turn that down slightly, that might help. So what I need to do now is fit these wires to the panel. So I'm going to try and work out how I can sit comfortably to do this. The white wire won't be connected to this. That's going elsewhere. So I put the light there. Put that sort of. Yeah, look at that. I haven't really got anything to put anything to sit the camera on. See. And annoyingly, this facing camera, I can't zoom it. So, right, what I'm going to do, this black wire is basically going to come up and it's going to fit into there. The red wire is going to fit into there. The orange wire is going to fit into this. I'm going to do that, then I'm going to be back, because otherwise you're not going to be able to see what I'm doing. Okay, so wires come down there, do tie wraps to the frame, and then as you can see, I've got these clips just holding them neatly as they come into the appropriate bus rails. The next job is going to be to see how far this white wire will go, because it needs to go all the way into that corner. I rather suspect it won't, at which point it's going to end up at a smaller panel clip here. Won't be on the panel, I'll screw it to the side somewhere. And that'll be that. So I'm going to see how far that will go. Perhaps unsurprisingly, there wasn't quite enough wire. Okay, the next step. You see this little connector thing here. If I drop board B temporarily, you can see what we've got behind all of these. Now let's bring the light back in. Let's see if I can. Needless to say, the light is just out of reach. So what I'm going to do is hold that there, turn the light on. Apologies for that. Anyway, try and get the stand on the back of it to come out one-handed. But anyway, right, a little bit of light. This is what we've got behind all of these boards. There's this connector block. Now, what I'm going to be doing is gradually, and it is going to be a bit gradual, decommissioning that. So what's coming out of it today is going to be the black wires, the black wire, the orange wire, and one of the two red wires, which obviously now come off this panel. They're not going to fit from there down to the panel, so that's going to be new wire. The first one I want to do, however, is board C, which is through here, because that is where the power to the layout used to come from. So if I reconnect board C, I should be able to power on and test it, and that will at least tell me I've got power coming where I need it to. So that is what I'm now going to do. And the way I'm going to do it, I'm going to remove its version of these wires completely. They're going to be disconnected at this end. They're going to be disconnected at the panel end. And then I'm going to replace new wires down to here. I'm not going to remove those. Well, I have removed them from that side. They're no longer connected to the panel, so this bit won't power up. So yeah, I'm going to do that. It won't daisy chain anymore. That's fine. I mean, if you can't see the loose wires through there. So I'm going to get that done. Hook up, and then what I want to do is get to the point I can test whether the layout is powering up correctly still, or powering up incorrectly, as the case may be. So yeah, in a mo, I'll be back. Okay, boards. Yeah, let's move around a little bit here. Boards B and C are now powered, so we have incoming wires. I'll say that didn't fit, needless to say, but never mind, that'll be replaced at some point. Ground connector at the top, and you see what I mean about the wires are going to run across to these little clips. 5-volt logic and 12-volt, and they come out the side on these little clips, and off they go. And a very quick power on test. Boards B and C power up perfectly. The rest of the layout is still daisy chained through C, so it doesn't work properly yet. This is Saturday I'm talking now. I'm going to come back to this on Sunday and basically get the rest of them wired in. I did a quick measurement test up here, and that block is reporting 5 volts instead of 4 point whatever. So yeah, that works. Yeah, let's turn around here a little bit. Some wires have been removed from there as not required. They'll all go eventually, but for now that'll do. I've still got the 5-volt power lead coming through here. The redundant wires have been removed from this end, and I have a pile of cable over there. And so far, I've only had one mistake where I cut a wire too short. I forgot I need to be able to retract that board, and it was too short to let me. Fortunately, it was only one wire before I tested it, and I thought, but there we go. Anyway, that's it for Saturday. I'll see you all again very, very shortly when I carry on with this tomorrow. So I'll see you in a sec. Hello again. This is now Sunday afternoon. This wouldn't be Leopard Street if something hadn't gone wrong. I've run out of the crimps I need. However, this board here, where I had all sorts of relay chattering, power the power side of the layout up. I can't power the power side of the layout up, it's not plugged in. However, this is board D, and I had lots of flickery LEDs. The one that's flashing in blue is supposed to be flashing in blue. This one here was flickering. This was coming on and flickering a bit. These were flickering. They're now steady as a rock. I've measured up here 5 volts, 11.9, obviously ground. So, yeah, this has gone from 4.2, I think it was, to what it should be. So, hopefully, this is correcting things. I suppose actually I should really remove this bit of dead wire before it gets caught on anything. So yeah, there's a bit of decommissioned wire out on the floor. So where have we got to? Well, board D is now working. That's correct. Board A is working. Board B is working, which is this one with the incline. And board C is working. And all of those, lurch down here, come down into this panel. So again, I've got the ground connector at the top with the 4 wires at the bottom, logic, there's the 5-volt logic, and the 12-volt system here. And again, I've got no flickering, or flashing lights, but no flickering lights. It's interesting actually looking at these two, the 2 lights. They're very, very nearly in sequence, not quite. And they should stay very, very nearly in sequence, but not quite. Because they're microprocessors, they've got very accurate clocks. What this is actually showing is that one fired up very, very fractionally faster than the other, which I can live with. Yeah. So, this is Sunday. I've got to go and order some more of these red cable crimps, which I've run out of. And then I can carry on. But I'll be carrying on next week now because I'm away for a couple of days. So this is going to go out Tuesday. Wednesday, I'm going to try and do some trains running because I've not run trains for a while. The rest of the wiring, so I've got board E over there to do, board H, which is that one, G, which is that one, F, which is that one, the far corner. That's going to run round past this one's, and the others are all going to go around that way. And they'll fill in the next 4 terminals along here. So yeah, learning it's a little bit awkward working under the layout. And my knees and my back aren't what they once were. So trying to sit upright without leaning against something is a little bit awkward. Never mind. However, this panel is at least where I can get at it. So yeah, I've got to order some more of those. I need to order some more wire, which I'm probably going to do sometime towards the end of next week. The goal is to get this side of the circuit done first. I'm then going to be going back around and putting the other 3 lots in, which will be another 50, 60 quid's worth of wire to sort all of that out. So yeah, that's why that's taking a little while. But by the look of that, I've fixed one of the reliability problems. What I'm going to end up doing is testing. So during the week, so Thursday, I'll say I'm going to I'll power the rest of the layout up. I'll plug the auxiliary supply back in, which is in that mess somewhere down there. Because what I want to do is power everything up. And I want to see how reliable this board is. This is one of the ones that's been causing the most trouble. This one and this one had the lowest voltages on. Board F works because it's only got block sensors. There's no points on F at the moment. However, there will be, and there'll be a turntable as well. So that needs power being stable. But this one's had a few issues. For example, those two little red lights in there don't always switch on correctly, which I suspect is the same problem if it's not quite getting the right amount of power to the lighting chip. Those points randomly change as this thing down here resets itself. So, yeah, we shall see. Anyway, this has been Leopard Street. Thank you very much for your time, as usual. Comments more than welcomed. I have had a few comments which I will address. Yeah, this layout, I'm using a DCC bus ring. I had a comment that, you shouldn't really use a ring on this. It should be a star sort of configuration. On a big layout, yes. On a layout this size, it really doesn't make any difference. You can do it either way. However, because of the rewire I'm doing, it is going to a sort of a star configuration with spurs from a central board. So that won't be much of a problem in future. Those thinking, if you think a big layout without all the block detection stuff, if you're busily thinking, well, you can't have the DCC in a ring. Yeah, the rails are a ring going all the way around. So having some wire as well probably doesn't make a lot of difference. Anyway, never mind. Other ones, people who... I want to make this very, very clear. I'm not aiming this at anybody, but I've had a comment from somebody who says on their videos, they get a lot of people coming in saying, oh, you mustn't do it like that. You must do it like this. There's lots of ways of skinning cats. I'm more than happy for people to say, you Burke, don't do that. That's wrong. That's not going to work. Yeah, because let's face it, half the time you're right. But I find bludgeoning through this sort of thing actually quite interesting. But just be careful when you're commenting on some people's videos. It can put people off. It can come across as a little bit gatekeeperish, which I know it's not. I know that's usually not how it's intended, but that's how it can come across. And just to reiterate, that is not aimed at anybody who makes comments on these videos at all. I have no issues with that, but it's something I've seen. The same as you get some people seem to enjoy being gatekeepers about how things can happen, who can do things, who can be part of the hobby, yada, yada, yada. I mean, you'll see people, there's a few, Loading Gauge Lucy, she puts a channel up, and to be honest, she's far, far better at model railway stuff than I am. Probably far better at this than I ever will be. And you'll see all sorts of lovely patronising comments about how it's wonderful having more women in the hobby. It's wonderful having more hobbyists in the hobby. Just think of it like that. Anybody can do this stuff. This stuff is not technically very complicated. We all enjoy it. We all enjoy it in our own ways. Let's keep it that way. Keep it nice and friendly. Keep it welcoming. The model railway community is small enough as it is without trying to fracture it and put people off. Anyway, lecture over. I've got to finish doing the lights in those buildings at some point. Once the electrics on the layout are stable, I've sort of got a bit of track down over there. Anyway, I'm going to get back to that. Anyway, thank you for your time. I will catch you all again in the next one. This has been Leopard Street. Thank you very much, and goodbye.